Okay, welcome to the challenges video. As you work through these challenges, please submit them in your OneNote section. But by all means, work collaboratively. All right, let's move on to challenge 1, area of obtuse triangles. Now, if I was to draw a box and then cut that box in half with a diagonal, if this box had a height of h and a base of b, then it's obvious that this triangle would have an area of b times h divided by 2. And it might take one extra step, but if I was to draw another triangle in a box just like that, then its area would also be bh divided by 2. But what about a triangle that is obtuse and has a base of b and a height of h? This area is not so obvious. So this challenge will be all about working out this area. If you don't want any hints, I suggest you pause the video now. For the rest of you, let's move on to part A, where I'm going to paste in that triangle. And if I draw a right angle that contains that triangle, what is the area of this right angle triangle? And a hint will be that we can call this little spot here x, and let's not forget that this length is b. Okay, so the hint is to use x and b. And in part B, my question is, what area needs to be subtracted from the larger green triangle to get back to the original white triangle? And finally, part C is, taking into consideration the areas of A and B, what is the area of the triangle? Alright, that should be enough for you to solve that. Let's move on to challenge number 2, area of a circle. The method that we use here is actually the beginning of calculus. So for this challenge, let's imagine we have a circle with radius r. Part A is, what are the rules for the area and circumference of this circle? Part B was, if we were to cut a tiny ring of the edge of this circle and then laid it out flat, how long would it be? So let's just draw what that would look like. And in part C, the question is, if we cut another ring off the circle following this cut, would it be longer or shorter than the first ring? So let's draw that one now. We're going to continue cutting the circle like this from now on, and from this point, assume that all the rings are the same thickness. Perhaps this picture may help. And part D is, if I keep on cutting rings until the whole circle is unwrapped, then stacked all the rings upon each other, how high would this stack be? Perhaps this diagram might help you a little bit. So in other words, they keep on stacking to the top of that blue line, and we're trying to figure out how high it would be, i.e. what is h. Then in part E, I want you to use the length of the first ring cut, the change in length from one ring to the next, the length of the last, almost inner ring, and finally the height of the stack of rings. To now draw a simple shape that estimates the stack of rings, and then state the area of this shape. Alright, in challenge 3, we're going to use what you know about the areas of triangles and rectangles to show why the rules for the area of parallelograms, trapeziums, rhombuses, and kites must be true. You're going to also need the rules of parallelograms or quadrilaterals, particularly their diagonal lengths, to draw some containing boxes, and to recall that if x plus y equals a, then x times b plus y times b equals x plus y times b, which equals a times b. Alright, at this point you should pause the video if you don't want any hints. Alright, part A is the rhombus, and I'll draw one of those with a containing box. And let's remember that the diagonals are perpendicular and bisect each other, and that implied that the diagonals are these lengths. And as we pointed out earlier, 2b is equal to y and 2a is equal to c. Sorry, I should have said 2b is equal to x and 2a is equal to c. Just another case of me saying one thing and writing another. Anyhow, from here you should be able to work out the areas of the triangles and then add them together. Then you'll be able to show that the area of the rhombus is x times y, all divided by 2. Okay, Matthew from the future is here. While I'm editing, I've realised I've made a mistake. That 2a should be equal to y. And let's check out the box to see why. So the 2a's there add up to make that y. Okay, apologies about that mistake. Hopefully some of you could see it. Bye. Alright, part B is kites, and I'll draw one now. Now I'm not going to say much about this one other than use a very similar technique to what we did with the rhombuses, i.e. the diagonals. Alright, in part C, let's have a look at a parallelogram, which has two sets of parallel lines. And we know from earlier work in this unit that opposite sides of a parallelogram are the same. And we'll name those B and A. To work out the area, we're going to cut triangles off the edges. And if one triangle has a base of X, what is the base of the other triangle? After we've removed those triangles, we have a rectangle with width Y. Now what does X plus Y equal? What is the height of the rectangles and the triangles? And then use this to work out their areas. Then add all the areas together and make this area equal to B times H. Finally, part D, we're going to look at a trapezium that has this length A and this length B and a height of H. Now first we'll cut off two triangles and we'll give one a base of X and the other the base of Y. This then leaves us the rectangle A times H. What does X plus A plus Y equal? And then finally add the areas of the triangles and rectangle together and use X plus A plus Y to make the area of the whole trapezium equal to A plus B divided by 2 or multiplied by H. I have an extra question for you. Draw the trapezium where the short side A is equal to 0. What shape is this? Does the rule for the area of the trapezium work to describe the area of this shape? Alright, and lastly, challenge 4, round peg, square hole versus square peg in round hole. Okay, let's work with the square peg inside a round hole. Firstly, draw a circle and the square that fits in it. Okay, just like this. Draw a radius in this circle that goes exactly to the corner of a square. Then you can state the area of the circle. Then you can figure out the area of the square. You'll need Pythagoras. And once you have those two areas, what proportion of the circle is covered by the square? Okay, let's have a look at the round peg in a square hole now. So first we have to draw a square with the circle that fits in it. And let me do one of those now. And of course, being a square, all these sides are the same length. And we'll say that this circle has a radius r. So step 1 is to state the area of this square. And then step 2 is to state the area of this circle. And then you'll need to say what proportion of the square is covered by the circle. And then finally we reach our conclusion by stating which proportion was bigger. And what does this tell you about which fits better into the other? Alright, I'll leave it at there. There's 4 challenges, that's quite a bit of work. Good luck with that all, and I'll see you in the next video. Bye.